Hello, and welcome to 5 Minute Math. My name is Aaron Daffern, and today we are looking at lessons learned from the fourth grade Mathematics STAAR 2024. What we're going to do is we're going to look at the readiness standards in which students across the state of Texas scored at 60% mastery or below, and we will look at the problems themselves, why students might have struggled, and what are the instructional implications for us as educators. So we're going to start with our lowest readiness standard, 4.5D. We had 32% overall mastery. What we're doing is we're solving problems related to perimeter and area, and we have two problems that were assessed here. And you see that on number 9, it wasn't that difficult as compared to number 24, but this one is still difficult, and this is a type of problem that we might even see on a fifth grade uh, STAAR because they're asking us to relate perimeter and area, both areas that are fully developed in fourth and fifth grade. So we've got the perimeter equals 40. So students had to, from this, derive that since it's a square, each side is equal, right? And then each side is 10. Then I've got to use my formula for area, right? And I've got to say, all right, so area equals the side times the side, or the side times itself, or side squared. And so that's 10 times 10, and that's your 100. So only 42% of our students were able to get C correct. Now, number 24 seemed to be a lot more difficult for our students. We need to find the area of the floor in square feet. And so this is a composite shape. Now, composite shapes actually don't show up in fourth grade standards. They show up in third grade standards. So since they're from previous grade levels, they're open for assessors to use to assess our students. So we just need to break this up into two, possibly even three rectangles, right? So one way to do it, there's multiple ways to do it, would be to make this a rectangle. So this is going to be a 10 by 12, right? So that's 120. And then this longer one is going to be 24 by 8. And so let's see what 24 by 8 is going to be. That's going to be 16, 19, 192. So now I need to add my 192 and my 120, because that's what happens when you get composite shapes. You get non-overlapping areas that you can just find the smaller pieces and add them up. So you're going to get 312. D is our answer there. And so what does this mean for us, and why did students struggle? Well, students had to derive the dimensions of a square given the perimeter to calculate the area of number 9. So you had to use the perimeter to find the area. So that's a different type of connection because a lot of times students learn this one at a time. It's either area or it's perimeter. And now they had to navigate between both of them. And then the area of the composite shape was definitely difficult, and that's standard 3.60, like I said. That's a third grade standard. For number 24, the composite shape, most students actually chose 36% chose C. So let's go back and look at this. 22% got it correct, but 36% chose C. And how would we get C? 88, literally add all the way around. So students, they might have recognized the word area, but then it wasn't a rectangle, it wasn't a square, so they really didn't know what to do. So they just found the perimeter. So we really need to stress the difference between the area and the perimeter, and then also remind them of how we can find the area of composite shapes. They did it in third grade, so they could do it again in fourth grade. And then we need to practice composite figures. Practice, 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 finding area multiple ways, right? So we did it that particular way. We also could have split it up, right, with this rectangle here, and then this other smaller rectangle. Or, like I said, you could even do three rectangles if you really wanted to. You can have a smaller rectangle there, and then two other smaller rectangles. And when we do that, let's practice the composite in multiple ways. Let's also practice perimeter so they see how they're different, right? Practice seeing how they're different units and they're different measurements and they're just not the same thing. Our next lowest readiness standard is in reporting category 2. This is 4.4H, only 35% mastery asked one time, we're supposed to solve with fluency one and two-step problems involving multiplication and division, and sometimes we need to interpret remainders. So look at what we have here. Xenia had some hair bows. So look at this. In the second clue, they're going to give us the total. So I'm going to automatically draw a strip diagram, and I'm thinking total goes up here. Okay, so I've got 400. So we need to help our students think when they see a total or when they see anything that might even clue them into a total, that's going to be the hole in the part in the top of the strip diagram. So made each hair bow with 7 ribbons, filled each box with 3 hair bows. Okay, so I've got 483 ribbons, and then each hair bow was made with 7 ribbons. So my first question is how many sevens can I get out of the 483? Because if each hair bow, right, equal group, that means multiply or divide. If each hair bow is made out of 7 ribbons, and I've got 483 total ribbons, well, how many hair bows can I make? I need to divide there. So let's divide 7 into 483. So that's almost going to be 7. That's going to be 6, 42, and that's going to be 63. That's 9. All right, so I've got 69 hair bows. Now, each box is filled with 3 hair bows, so I almost need to make a second one here. I've got 69 hair bows, and then each box is filled with 3 hair bows. It's that same thing. How many 3s can I get out of the 69? So I have to divide twice. And this might be why students struggled, because that's a lot of division, especially with division being long division like this being really mastered for the first time in 4th grade. And so it looks like we're going to end up with 23. Right, so our answer here is D. Only 35% of our students got that. So we had to divide twice. Almost as many students chose A, 29%, as those who chose the correct answer. A was 161. And what that 161 is if we just ignore the 7, this is just the 483 divided by 3. Not sure what happens to this, but if you do your 483 divided by 3, you get your 161. So they knew division was there somewhere. They only wanted to do that one time, though, and that was 29% of our students that got A, almost as much as those that got the correct answer. And so strip diagrams. You saw me represent this problem with 2 different strip diagrams. A strip diagram is what helps students understand the relationship between the quantities in a problem. So it's the strip diagram. If I can make it make sense in a strip diagram, then I know which operation I need. And so we need to have model for students that they can have multiple strip diagrams, because if every single one of our problems only has one, they don't necessarily know how to draw a second one, or even know that they can draw a second one for a 2-step problem. Next, we're looking at 4.3e. We have 39% overall mastery. We're representing and solving addition and subtraction of fractions with equal denominators. Now, in 4th grade, it's equal denominators. In 5th grade, we're not necessarily worried about it being equal denominators. And so this is an interesting problem because it's equation, right? It's a text editor. But honestly, we don't even need to add here. Watch, what fraction of the shirts are either solid or striped? Well, when we have a fraction, we know we have a numerator and denominator. So the way that STAAR wants you to do it is this. How many solid do we have? I've got 1, 2, 3, 4, 5 out of 6, 7, 8, 9. Okay, 5 ninths. How many striped do I have? I've got 1, 2, 3. I've got 3 ninths. So 5 ninths, 3 ninths, right? That's going to equal 8 ninths. But since they're sitting right there in front of you, you don't really even need to add. You can just group those together, right? And you can say 1, 2, 3, 4, 5, 6, 7, 8, 9. Once you've identified your solid and your striped, it would be 8 out of 9, right? And then you're just good to go there. So the answer is 8 ninths. So that's a strange fraction. A lot of times students don't deal with ninths, so they might have thought there was a difficulty there. The thing is in order to get this problem, you have to use this fraction button first. You have to push this first, then you have to push the 8. Then, when you do that, you've got something that looks like this, and there's a little gray bar in the denominator. You have to click that gray bar with the mouse so that the equation editor knows that you want to switch from the numerator to the denominator. Then you have to click the 9. You see how there's 4 different clicks there? Have to click the fraction button, and then the 8, and then you click in the denominator, and then click the 9. That's a lot of clicks, and it might not be intuitive for the kids. I think that might have messed them up. Also, if you click in the wrong order, so if you click 8 first, because you think you're just going to do that, and then you click this, so if you go 8 first, and then you click the fraction button, what it thinks you want to do is it thinks you want to make a mixed number. So 8 is your whole number, and now you're needing to fill in the numerator, and that's not obviously what we need. So you have to click the fraction button first. So all that put together made this 39% mastery, right? So we had to interpret a fraction, a picture to name fractions, right? And then the fraction button, like I said. I really do think if this was multiple choice, we would have gotten so much higher. It's the fraction button. This is one instance in which the tech enhanced items might have hurt some of our students. So we just need practice to get on Cambium, get on the practice problems, and just let them enter fractions. Just get them into a computer lab or maybe just demonstrate something and just put it up on the screen and let the kids see you enter fractions on a fraction problem or on an equation editor problem, just so they can see the correct order of how to enter fractions. And then, like I said, you can show how the picture gives the answer without even needing to add fractions. That's what I did second with my blue marker, showing that you can just count all the solid and striped, and that's your 8 right there, and then count your total for your 9. So we don't even necessarily need to add fractions on this. We can just count the picture, and that will give us exactly what we need. Next, we're looking at 4.8c. This is in reporting category 3. We only had 40.5% of our students get this correct. Solving problems, but look, we've got measurements of length, intervals of time, liquid volumes, mass, but look what both of these happen to be. Both of these happen to be money, but this standard could be anything, really. Okay, so we did okay on this first one. 61% of us were able to figure this out. Kiara had 15 cents in a jar. She adds these coins, right? So I just need to add 25, 25, 25, right? So that's 75. And then I've got a whole bunch of 10s. 10, 20, 30, 40, 50, 60, 70, 80. And then I've got 2 5s, right? That's a 10. Now watch what happens if I just add these three. I've got 75, 80, 10, 5, 15, 165. $1.65. Not even there. If that was there, we probably would have tripped up some kids. We also have to remember the 15 cents. So since I'm in dollars and cents, let's do that. It's the 180. So we had 61% of our students do this. Anytime we're above 61%, it's at least not a huge problem. Obviously, we want to get above 70 if possible, but 60% or above is decent. This one, number 16, look at this, 20% correct, but it's another tech enhanced item. You either got it right or you got it wrong. So we had this amount of money left over after buying a snack. So let's figure out how much money we have showing. We got 10, 20, 30, 45. So I've got 45, and then I've got 25, 50, 75. These are dimes. 85, 95. I've got 45, 95 left after buying a snack. I used $50 to buy a snack. So students had to understand what is change and what does that mean when you have money back. Because if we could get data on what students are entering, which we don't on a problem like this, I would bet so many students are entering 45.95 because they're not reading the problem, they're seeing the picture, and they're just counting that up and they're thinking, oh, this is an easy problem. The problem is not to add a collection of coins and bills. The question is to calculate right? So how much money does he have left in dollars and cents? Well, now I've got to calculate my change. I paid with a 50. That's a bit strange. I'm not sure why I would buy a snack with a $50 bill. So that's a little bit unreal. But we have to do all this regrouping here. And we know that regrouping can sometimes still trip our kids up. And so this is going to be $4.05. So I have to hit the 4, then the decimal, right? So obviously some kids might type in 405 without the decimal and get that wrong. So that's that particular problem right there. Now, let's see what that means for us. For whatever reason, this year 4.8c involved money in both problems. But look what else they can add. Intervals of time, liquid volumes, mass, length. It's just difficult to prep for the standard because there's so many different things it could be. We did okay with the first problem, fairly straightforward. And then the second problem, as we just saw, number 16, was a lot more challenging. We had to count bills and coins and then calculate the change and then had to enter the exact amount. There's no A, B, C, or D for us to choose from. And so we need to give students problems that involve money, including calculating change, and then remove all answer choices. That's the best way we can simulate the equation editor is give them problems like this. Say you paid with a 20, you paid with a 30, you paid with a 40, with $30, with $40, $45. Probably you want to give them a amount of money you're paying with whole numbers, not necessarily decimals, because I think part of the problem might be subtracting and regrouping. And then we need to ask a variety of questions from a collection of coins because it's not always going to be a change question, right? Maybe how much more money, if you have this collection of bills and coins, how much more money until she saves this amount of dollar, which is going to do the same thing. You still need to subtract, but we need to ask it in different ways. Or if she adds 3 more dimes or 4 more quarters, how much money does she have now? There's a lot of different ways we need, when we're working with money, we need to get students to think about it and not always just counting it, period. Asking for change, how much more money you need, things like that. Those are always going to help our students. So looking at 4.7c, this is an reporting category 3. We had 46% mastery, and we're just determining the approximate measure of an angle to the nearest whole number using a protractor, 95 degrees. Only 46% of our students could correctly calculate 95 degrees. Now, we need to be thinking of just our basic number sense and our angle sense in this case. This is a 90-degree angle, right? It's a right angle. Our student should know that it's not always going to be perpendicular like that, but that's a square corner. And so 95 is really close to 90. So I'm thinking it could be A. It's not going to be B, even though B picks up 95 on both of these measures. It's too skinny. Could be C and could be D. All right, I've already eliminated one answer. So I'm now 1 out of 3. Okay, so how do we measure this? Well, since it opens to the left, we always want the array to start on 0 if possible, right? And so we've got a 0. Since that 0 is on the outside, we're just going to go to the inside. In this case, 90 is the same for both. So this is a perfect 90-degree angle, not 95, so we don't need that. C, it's opening to the right, so we're going to go from 0 on the inside all the way up to, look at that, it's 85. It's 95 if we count it on the outside, but we're not counting on the outside because our 0 is on the inside. So it's not this one, so we have to subtract. It's not always going to have a ray starting at a 0. So let's start on the low number there, on the outside, 10, and on the outside here, I've got 105. So I've got 105 minus 10, and that's going to be 95. If I wanted to, I could also do it from the right, if I really wanted to, right? So that's going to be, you see this right here, on the inside, I've got 75, and then also on the inside, right, I've got 170. You can count the inside and inside or outside and outside. It doesn't really matter. Just be consistent. And that obviously is still going to be 95. You just had to regroup. So our answer here is D. And so you had to subtract measures in order to find that. The other two options that were close just had a ray at the zero, which probably tripped some kids up. And almost as many students chose C, 38%, as D. Let's go back and look. 38%. Now, why would 38% of our students choose C and 46 choose D? Well, it looks close. It's on the 95 right there if you're using the outside measure. Of course, we're not using the outside measure because that 95 and that 180, if you do the 180 minus 95, you're going to get 85, not 95. And it's easy. It doesn't require any subtracting because they knew that one of the lines started at the zero, just not the correct one, right? It started on the inside, and so they needed 85 if they're near the inside. So we need to continue to work with our students using actual protractors, right? So have them use actual protractors, have them draw an angle that's so many degrees, and then calculate it multiple times. Have them keep rotating with still the center in the middle, but have them rotate it like, certain amounts clockwise or counterclockwise and calculate it again and again and again so they see that an angle measure stays the same no matter how you rotate it, whether you're counting between these two or whether it's lined up on one of the 0 or 180 marks. And then that reasonableness and right angle could have at least eliminated one answer choice, right? That is answer choice here. B, we should have eliminated simply because it's too small. Next, we are looking at 4.3D. This is comparing two fractions with different numerators and different denominators. And we have only a 48% overall mastery. We did okay on this first one. We're simply trying to find a fraction that is less than, or 6/8 is less than. And we would just need to take each of these fractions and find common denominators, which is going to be difficult for some of the students. But if we started with the fifths and the eighths here, we could just multiply each of these fractions by the other denominator. So I can multiply that by 8, by 5 to get equivalent fractions. So that's 32/40ths, and this is going to be 30/40ths. So if I replace the 6/8 here with 30/40ths, and it's less than this 4/5, which is 32/40ths, right? The trick here is to make sure that we have the same denominator. This one actually works. So the first answer is correct. If they wanted to, they can go through and check the rest, but those are going to be incorrect. And so it's the second one that requires a little bit more work. You notice that we have improper fractions for all of these, so that might have thrown a few kids off. And we've got 4 fractions altogether, so let's go ahead and get them all into the same denominator rather than one at a time. But we'll notice, hopefully our kids are saying, all right, I've got 2 different 12s and a 2 and a 6, and 2 times 6 makes 12. So really all I need to do is I just need to change my 17 halves times something. It's going to equal 12, so that's going to be 6. And it's going to be 102. So I need to replace this with 102 over 12. And then I've got my 60 over 6, I could just double that. That's going to be 120 over 12. And these are some of the relationships we want our students to be able to see here. And so I can, since they're all 12s, I can just use the numerators here. So my purple, right, my purple is 90, is less than the width of the red, 102. And all I need is the numerator since my denominators are all equal, right? So that looks good. Let's make sure the other ones are incorrect here since we've already got them all laid out, and we'll see which one really tripped our kids up. The width of the black tablecloth, that's 120, is less than the width of the purple tablecloth, 90. No. The width of the red, 102, is equal to the width of the black, 120. No. And then the width of the green, 126, is equal to the width of the purple, 90. Obviously, no. So only 37% of our students were able to get A correct. But let's look at this. We did fairly well on the simple comparison, one at a time. And for number 22, the second one, we had to compare 3 different denominators. They were all improper fractions, But more students chose B than chose A. So let's go back and look at B. B got 40% of our students here. The width of the black, now let's look at the originals. The black says 60 over 6, and the purple is 90. So if we're just comparing the numerators, then yes, 60 is less than 90. So I have a feeling, rather than changing to equal denominators, students were just looking at the numerators and saying, oh yeah, 60 is less than 90. So this requires our students to take that extra effort to change everything to same denominators, so you can just compare the numerators. We need to give them practice comparing fractions with 3 or 4 different denominators, like we did on number 22. Rather than just 2 at a time, like the first one, have them change 3, even 4. Now, it needs to be fairly simple, like we did with our 2, our 6, and our 12, right? That works, because if you're going to make them compare like 6 and 7 and 13 and 19, no one's going to want to do that. So make them fairly easy fractions to work with. And like we did on one of ours, we need to be able to use reasoning to quickly compare fractions, right? So if we can just look at this 60 over 6, and we just think, if I want to make that into 12, I don't need to do this whole full algorithm here. I just double it. Just double the 60, double the 6, I got my 12, and we can quickly generate equivalent fractions to make those comparisons even faster. Next, we're looking at 4.5a. This is in reporting category 2, and we're representing multi-step problems involving all 4 operations using strip diagrams and equations with a letter standing for the unknown quantity. We had 50% overall mastery, and as you can see here, we had an inline choice here for number 23. So let's look at that one first. So Caroline and David each own a flower shop. Caroline had 156 red, 142 yellow. And then Caroline had 39 more tulips in her shop than David. So let's draw a strip diagram first, then put that into an equation. Okay, so Caroline had, it's going to draw this. Okay, so she had 156 red. She had 142 yellow. Now, put those together, right? That's how many she has. She had 39 more than David, so now I'm comparing. So this is Caroline, this is David. She's got more than David. So I'm going to draw that same amount, and I'm going to say that I'm going to just draw these little hashes here to say this is more. This is what she has more than him. So I need to figure out T, how much David has. So how could I do that? Well, I need to figure out how much that she has altogether. So 156, 142. Let's add those up. That's going to be 892. Okay, 298. So we have to add these two. But then what do I do with that 39? Okay, well, I need to compare that. I need to take that away. So, right, I need to subtract 39. And then that is going to get you 259. So we actually have to subtract. So we're just choosing the correct operations here. As you can see, only 37% of our students got full credit on this one. That means they got both correct. If you got partial credit, you got 1 out of 2 correct. We don't know which one they got correct more. By guess, it was probably this first one. I would think a lot of students just added both times rather than drawing that strip diagram to represent it. So what we do is we take half of this 37%, right? And so that is going to be 18.5 or 19%. We add that to the 37% that get full credit. So we basically take all the full credit and half the partial credit. We add those together. We say, all right, so we had 56% mastery on this problem. So we did a little bit better on this one. Let's take a look at number 7. Because on number 7, we only had 44% mastery. So we've got Duncan and Priscilla. They're buying 68 apples. They use 46 to make a pie. They split the remaining apples evenly. Well, we need to see first, when you buy 68 apples, we're now getting our total. So I'm going to put our total up here, 68. So I can recognize that I've got my whole. Now I'm looking for parts. This is a part whole problem. So we are going to use 46. So I've got several parts coming here. So I'll say 46. I'm not going to try to make it proportional. To make pies for the sale. And then they split the remaining apples evenly between the two of them. So there's two of them. So they're going to cut it in half like this. And A is the number that each of them have in their equal group. So I can just put an A, I can put an A. So our answer here, right, we see is D, but only 44% of our students were able to get that. And so we had to use the strip diagram to represent both that subtraction. And really what this was is that was division, splitting evenly. And so they had to use that strip diagram to represent two different operations, right? And we also had to correctly interpret that split evenly means to divide by 2. So as you saw with both of these, before I started putting them into strip diagrams, I drew my own strip diagram, or before I put it into equation, I drew my own strip diagram. And we had to first figure out, is this a comparison problem, which this one is, or this was a part to whole problem? Because we can use strip diagrams for both of those, but they're going to act a little bit differently. And so what can we do to help our students? Draw strip diagrams. Again and again and again, when in doubt, we're solving word problems and we think we're involving basic operations, see if we can draw a strip diagram to represent the relationship, especially to decide whether we're looking at a comparison problem, like we did on the first one, or a part to whole problem, because those are relationships that we've been looking at ever since kindergarten. And then we need to teach students to solve each problem in addition to representing it to check their answers, right? So if I was unsure, what I could do is I think my answer is 259, so I can use this equation to double check my work. Does 156 plus 142 minus 39 make 259? I didn't really solve this one here, but I can solve this 68, this 46, and I can find what that is and see if that works here for A. But you could double check your work by actually solving it, not just representing it, and then plugging that back in. So next, we're looking at 4.5b. This is in reporting category 2, only 52% overall mastery, input-output tables for students. And the pattern is always following a given rule representing the relationship of the value to the sequence and the position in the sequence. So let's look at number 10 first. Rule equals -4. Now, this is a three-part. You notice our tables over here are three parts. There's the position, and then there's the expression, and then there's the value. So the rule is between the position and the value. Okay, so I've got my position, and I've got my rule, and I've got my value, right? So my position, let's start with A, right? So I've got 10, so I should -4, so that should be 6. You see, we're automatically wrong. 11, rule -4, that should be a 7, so that one doesn't work. So that's how we're going to evaluate this here. Take a look at B. My position doesn't change. 4 minus 4 is 0, but then 4, they changed this to 5. There's no 5. The position is not changing, but my values are changing. So that's not going to work for me. Now, I've got a position, then a value of 4, but that's a -0. I don't need a -0. I need a -4, not a -0. The only one that's got a -4 is that one right there, but now we've got a -8. And I've got a -12. So these first three aren't working for me. This last one, look, right there, -4. 10 minus 4 is 6. 11 minus 4 is 7. 12 minus 4 is 8. 13 minus 4 is 9. So 47% of our students were able to get D correctly. Now we only have two columns here, so I just need to apply +7. But it's our input +7 to the output. So that's not going to work because that's a +6. And that's a +12. Honestly, what we're doing is we're doing a +7 all the way down, but not between the input and output. This is a +6. This is a +6. +6. Not working. And it's a +1 all the way down. So either way, it's not working. Now, 1 plus 7 makes 8, 2 plus 7 makes 9, 3 plus 7 makes 10, 4 plus 7 makes 11. So that works. This one has a plus 7 at the beginning, but now it has a plus 14, right? Plus 21. That doesn't work. So our answer there is C. 57% of our students got that correct. So both problems involved an additive relationship. Doesn't always have to be an additive relationship. Sometimes it's multiplicative. And for number 32, let's look at it. 30% of our students chose A. So go back to number 32. This was the plus 7 all the way down. 7 plus 7 make 14. 14 plus 7, 14 plus 7. 30% of this were looking for the plus 7, but they didn't know to look between the input and the output. They were just looking straight down the output. So 30% of our students choosing the same incorrect answer means we have an misconception. And so what can we do? Well, we need to make sure that our students know that the rule is applied from the input to the output, regardless of the orientation of the table. So sometimes the tables are going to be vertical, sometimes horizontal. We need to make sure that they're seeing it from side to side rather than from up and down. And we need to give students practice adding that third column. I think that might have messed some of our students up on number 10. So that third column of including that expression would be good practice for some of our students. So for 4.4a, we are looking at reporting category 2, 55% overall mastery. We just have to add and subtract whole numbers and decimals using standard algorithm, but we have to figure out what exactly we're doing. So we're buying a roll of craft paper for $7.99. Okay, so I'm just going to kind of put this together here. And then I've got some glue for $3.69. Okay, so I'm just going to add these two here. Draw a strip diagram, $3.69. Now, what's interesting here is I'm going to save 75 cents. I need to know what that means. Saving 75 cents by a coupon, that means is I'm going to take this little chunk right here. I'm going to shave that off. I'm going to put that down here because I'm actually taking that away. So what I need to do is I need to add $7.99, $3.69. So I'm going to represent it with the strip diagram first. 18, that's 10, that's 16. It's 11.68. Now I need to subtract that 75 cents because I'm saving it. So that is going to be, let's make that a 9, 10.93. Only 55% of our students were able to get that correct. And it's just basic decimal addition with and subtraction with regrouping. The save and the coupon, that's what they had to figure out. That meant subtraction. So, still, what did I do to solve this? Draw a strip diagram. That's what students should do to figure out the relationship between that 75 cents and the other two quantities. And then we need to help provide them vocabulary. So multiple terms for real life situations that denote addition or subtraction. Because if you're putting into a word problem, there's many ways to get a student to add or subtract without saying the words add or subtract. And if they're not used to that particular term, they might not know that that word means to add or subtract. We need to provide them opportunities there. 4.2g, we are looking at reporting category 1, standard relating decimals to fractions. And as you can see, they're both going to be improper. These are both going to be greater than 1. So we need to make sure our students are not just practicing with proper fractions or decimals less than 1. So 29 tenths. Okay, so let's look at our place value here. So if we've got our tenths place, I can label it like this. This is our ones place. I can label it like this, right? So if I've got 29 tenths, that's going to look weird because we can only put one digit in one spot. So what we do is this just spills over right there. And I can say 29 tenths is the same as 2 and 9 tenths. It's a big idea for some of our kids is naming something. But if I were to say I had 10 ones, right? It's that same idea. 10 ones we know is 10, but we can use that same property. Here's my ones place. Here's my tens place. Can't put two digits in one spot, so I just shift it over. and my 10 ones becomes 10. Same thing with 29 tenths becomes 2 and 9 tenths. And then we've got these equivalent fractions here. So this we can automatically eliminate because 8 and 5 hundredths, right, is going to be larger than 1, and 85 hundredths is less than 1. So maybe this, not on this, because 85 hundredths is less than 1, 8 and 5 tenths is larger than 1. So we've already eliminated it down to just two possibilities. And this is 8 and 5 hundredths, right? So we can do it like this, 8 and 5 hundredths. Or we've got 8 and 5 tenths. Now we can use the same thing over here. And we can say, well, look, we've got two digits. So if I were to go into the tenths place, right, I can say 85, and I can just go ahead and spill it over, and look what I've got. I've got that 8.5 is 85 tenths. If I wanted to try this, 8.05, and I wanted to just go to the tenths place, right? I would need an extra digit. This would be 805 tenths would get us to that, and so those two don't match. So our answer here is D. See how we did here? They both involved improper fractions. We need multiple visualizations of how improper fractions and correct naming of decimals. Right, another way to do that, other than the way that I showed here, would be to use like place value charts. I'll use 29 tenths, right? So if we have our ones place, we have our tenths place, we can just put 29 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we should know is that when we're dealing with place value, each 10 of one place value can be um, grouped together, bundled together into another 10, or into one of the next place value. So I've got 9 left, so I've got two ones, and I've got 9 tenths. So that's another way to visualize it. We need to provide multiple opportunities for them to visualize how to build those numbers, and then we need to connect this, right? 10 ones equals 110, just like 10 tenths equals 1 1. We need to make that connection between whole number regrouping, which they're familiar with, and decimal regrouping, especially tenths into whole numbers. And then finally, let's look at 4.6D, 59% overall mastery. So we almost got to that 60% mark. There's just one problem here. We're needing to classify two-dimensional figures based on the presence or absence of parallel or perpendicular lines. 2-point problem, we say only we had 39% get full credit. That means they got both points. 40% got just one. We need to find perpendicular sides. There's no definition for students here on our reference material, so they just need to know what this means coming into it. Perpendicular sides, two lines that intersect at a right angle or 90-degree angle. And so hopefully we see immediately, okay, figure R works. And I would think that of the 40% that got partial credit, I would think R was the one they most likely got. The other one that's got the right angle is going to be this figure T. Like you see it right there, and you see it right there. You also see it externally there, but we're not really counting those external angles. And I think figure T is going to be tricky for some kids because that's just a non-normal shape. I mean, we know it's an arrow, but it's actually a heptagon or a septagon. You can call it either one. It's a seven-sided shape. We don't deal with seven-sided shapes much. So this is a non-standard problem. And so we would take half of our partial credit and then add that to the 39%. That's where we get our 59%. And we had 21% couldn't get anything, which means we really struggle with this term, perpendicular. So we most likely identified R, struggled to find figure T, and figure T was a seven-sided, very strange shape. We know it's an arrow, but we don't deal with that much. So we need to provide multiple opportunities for students to identify both parallel and perpendicular, but we need to find irregular shapes. Now they obviously need to be straight sides. They need to be polygons, so don't make them so strange to where they're trying to find parallel or perpendicular lines and arcs or rainbows or anything like that. They need to be closed with straight sides, but we need to get beyond trapezoid, parallelogram, rectangle, triangle. We need to move into different shapes. And that will help our students with all of the things that they need to do for identifying or classifying two-dimensional figures based on the presence or absence of parallel or perpendicular lines.